Good evening. I am going to start a brief lecture on the topic application of remote sensing and GIS for civil engineering. My name is Dr. Arnob Bormudoi. I am currently working as an associate professor in the program of civil engineering under the Faculty of Engineering and Technology in Assam Downtown University, which is situated in Guwahati. I'd like to first share the presentation that I have here. So as I said, the topic goes with the title Application of Remote Sensing and GIS for Civil Engineering. This would be an introductory kind of a lecture for the people or for the audience who is new to the subject of remote sensing and GIS. Remote sensing, before we start the subject, I would like to give you a brief overview that would help for the discussion that I am going to initiate in the presentation. At the same time, we should remember that GIS stands for Geographical Information Systems, which is becoming a very important tool for analysis of the data that we gather by remote sensing methods and technologies. The content of the presentation goes as shown here in the slide. First, I would like to give you a brief introduction to remote sensing, and then I will go for a brief introduction to the GIS subject, and then we will investigate what are the application areas that both these tools have, especially in the area of civil engineering. If I go by the definition of remote sensing, it says that remote sensing is the acquisition of physical data of an object without touch or contact. And it also is a science, but we should remember that remote sensing is also an art. So, knowingly or unknowingly, we human beings are doing remote sensing. So especially we do it with all 5 organs that we have. For example, we have our eyes, we have our ears, we have the tongue, we have the skin. These organs all are engaged in the process of remote sensing. Remote and sensing, that means without directly being in contact with the object of interest, we gather information. For example, if I want to taste something, I must put that in my tongue. So the moment I put this object I want to taste in my tongue, I am in contact with this object. So my tongue at that point of time is no more a remote sensor. But if I open my eyes, I see something and I interpret that object. Immediately I am engaged in the process of remote sensing. Similarly, if I hear some noise or if I hear some music at a distance, I connect to that music. I am doing Again, remote sensing, because our ears and then the source of the music is not directly in contact with each other. So when we are talking about remote sensing, basically we are interested in gathering these type of informations which are actually scattered on the surface of the art, or information that we can get from the atmosphere. Remote sensing is a science, and also this is an art. That means remote sensing depends on the tools, the methods, as well as the person. So with the same tool or the same set of information, our level of interpretation may differ from person to person. At that point, the dimension of personal skill, which we can say it's the art, comes into play. Here in the slide, you can see there are some vehicles which are carrying some sensors. For example, if you look at the left-hand side of the screen, we have a satellite, and on board the satellite we have some sensors. These sensors are similar to the sensors that we normally have in a camera. So these sensors actually capture information from the surface of the art or from the atmosphere itself. Again, there are other sensors. For example, we can put a sensor on board a ship, or we can even put a sensor on board a hot air balloon, which we can let it fly into the atmosphere and then engage these sensors in the process of data collection. We should remember that while we are doing all these activities, we need source of energy, and normally the sun is the source of energy. Let me explain it in this way. We all know that sun emits radiation in the form of various waves. We differentiate these waves in the term of their wavelengths or frequency. So what is a wavelength? Wavelength is the physical distance between two conjugative peaks or two troughs. So when these waves are being emitted from the sun, they are coming in a range, or we call it the spectrum of waves. That means these waves have various wavelengths. These wavelengths start with very small in size, and then gradually we can say that the wavelengths gets bigger and bigger. So when the wavelengths are very, very small, relatively, that wavelengths are actually shown in this section of the screen, towards the right hand side, here you can see, we name it as gamma rays, where the wavelengths are extremely small. When the wavelengths are small, the reciprocal, that is the frequency, is very big, or we call it very high. So gamma rays have very high frequency. So slightly bigger wavelengths than the gamma rays are within the category of the X-rays. So if the wavelengths are slightly bigger than the X-rays, we name it as ultraviolet. Then we have the visible range. That means this constitutes the wavelengths which the sensors in our eyes can detect. Roughly, they start from 400 up to 700 nanometers. As you can imagine, 400 nanometers is extremely small, as well as 700 nanometers. Within this visible range or visible light, we see all these colors that are present in the physical world. Towards the smaller wavelength within the spectrum, towards the 400, we see objects appearing to be blue. Then while we enter a slightly bigger wavelength, we see those objects as green, and towards the 700 range, we see these objects as red. So if you compare this range with the entire range of wavelengths which are being emitted by the sun's energy, this is a very small fraction. So why we are highlighting this visible light? Because in the process of remote sensing, we utilize these range of wavelengths. So if we engage these wavelengths in the process of remote sensing, these wavelengths or this remote sensing is known as optical remote sensing. In optical remote sensing itself, there is a slightly higher range of wavelengths which are also engaged. That means more than 700 nanometers. And if we cross that range of 700 nanometers and enter the other range, this is the infrared range of wavelength. So this infrared normally we cannot see because our eyes are not designed to capture information that is coming in a range of wave that has a higher wavelength more than 700 nanometer. But remote sensing does utilize this spectrum of wavelength, and we call it infrared remote sensing. Then if you go farther beyond infrared, we enter the microwave zone. Microwave, they have a range of wavelengths in the order of millimeters and centimeters, which are far bigger as compared to the visible light or the infrared. But Some sensors are designed to capture this range of wavelengths as well. So if someone is engaged in collection of information using microwave, that part of remote sensing is known as microwave remote sensing. So on the screen, this is visible light together with infrared. This is optical remote sensing, then infrared remote sensing, and then we have a microwave remote sensing. So remote sensing uses the visible range as well as the infrared range and then the microwave range. If you cross the microwave range, we enter the radio waves, which have even larger wavelengths, and normally remote sensing are not engaged in this range of waves. Okay, so coming again to the drawing in this slide on the left hand side, what actually these sensors capture, which are on board, either a satellite or a ship or a UAV or a hot air balloon. Basically, we should remember that remote sensing is engaged in capturing energy. So this energy can be divided into three types of energy. One is the reflected energy, another one is the emitted energy, and third one is the scattered energy. So as I said before, if we are using the sun as our primary source of energy, the sun's entire range of electromagnetic spectrum is being emitted, and depending on the wavelength, some of these ranges are entering our atmosphere, and once they enter the atmosphere, they come and then they hit the objects which are upon the surface. These objects may be some trees, they may be some buildings, or whatever. So once they come and they hit these objects, normally a part of the energy is either being absorbed or a part is being reflected. So once this reflected part goes back and then the sensor is being able to capture, then this is one type of energy that the sensor measures. This is known as the reflected energy. Another type of energy is that once the whole electromagnetic spectrum, once they are traveling from the sun, part of it is penetrating the atmosphere, and then it is incident on some of the objects. Some of the energy is being absorbed, and the object actually emits it in a different waveform. So again, if the sensor is able to capture that energy, this is the emitted energy. And again, if some of these energies which are coming from the sun are not being able to entirely penetrate the atmosphere because of the aerosol or the dust particles present, from the atmosphere itself, they are scattered back in all the directions. So somehow if the sensor captures this energy, this is known as the scattered energy. So basically, these three types of energy are being captured normally by the sensor. And we should remember that remote sensing is all about capturing the energy.